Okay, you guys do not need to take notes on this. This is more of just a listen and get so that hopefully Monday's lesson is a little bit easier. So we're going to start talking about some new functions. We already talked about quadratic functions. Now we're going to start talking about square root functions and cube root functions. We're going to talk about their domain, their range, where they're increasing, where they're decreasing, and we're going to do that using the a value to help us graph so that way we don't have to keep evaluating over and over again. It should be a quicker process. So let's start first with what we just took a test on, what we've dealt with all year, so x squared. X squared has not been moved left or right, so that means I'm right at my origin. If my a value is 1, that means I move right 1, up 1, that means I move right 2, up 4, and that means I move right 3, up 9, and then I can make it symmetrical points so that I can find my function. So here is my quadratic. My domain and range, so my domain, remember, is my x value, so it's left and right. This function is going to go left, it's going to go right, so my domain is negative infinity to positive infinity, which I do not include. My range is talking about my height. The function is going to go up forever, but it will only go as low as the height of 0. So my range is from 0 to positive infinity, but I do have to include the height of 0. My function is increasing and it's decreasing. It's decreasing first, though. So it's decreasing from the value of negative infinity until it hits the x value of 0, both of which I will not include. At 0 is when it switches to increasing as it goes towards positive infinity, both of which I do not include. Okay, so now let's talk about a different function. So this one right here, so f of x equals the square root of x. So here's your square root function. When we talk about graphing a square root function, we can talk about evaluating first, and this is what you're probably going to have to do for a while, but we are going to use the value of a to hopefully help us. So for instance, if I use these as my x values as my domain, if I were to do the square root of negative 2, I can't take the square root of a negative, so that's nothing. It'd be an imaginary number. We don't graph imaginaries. Whereas the square root of 0 is 0. The square root of 1 does not end up being a nice number in terms of it being a whole number, so I'm actually going to skip it. The square root of 2 is the same thing. The square root of 3 is the same thing, but the square root of 4 is 2. So we actually end up skipping these values of 1, 2, 3 so that we can plot the point 0, 0, plot the point 4, 2. And if you think about what numbers you can take the square root of, 9 is a really nice one because then it gives me the value of 3. So I could go over 9, up 3. And then this is what my function will look like. And it keeps going up, it just goes up very slowly. Okay, my domain is starting from the x value of 0 and going towards positive infinity, and it includes 0. My range, my height, is starting at a height of 0 and also going up towards a value of infinity, and includes 0. This function, if we follow it, is not decreasing, so never, but it is increasing over its entire domain. So it's increasing from 0 to infinity, and we do include that as well. So unlike the quadratic that increases and decreases, this one will only increase. Unless we flip and if we make a negative, then it would do this, and it would make all of these be the mirror image, and then that function would actually only decrease instead of increase. So it matters what our a value is doing. Okay, so the big things with this is when we go over 0, up 0, when we go over 4, up 2, over 9, up 3. So these are the important points to notice. Notice that we're not squaring them, we're square rooting them. Okay, and we're picking perfect squares. So over 0, up 0, over 4, up 2, over 9, square root is 3. Okay, oops, I erased this somehow. This was 0 to infinity. Okay, and the next one is our cube root function. So our cube root function is saying, like, when we take the cube root, it means what times itself 3 times gives me a number. For instance, what's the cube root of 0? Well, that's 0. What's the cube root of 1? That means what times itself 3 times gives me 1. Well, 1 times 1 times 1. So the cube root of 1 is 1. The cube root of 4 is not a nice number, so we kind of skip over it and we don't use it. The cube root of 8, well, 2 times 2 times 2 is 8, so the cube root of 8 is 2. And now cube root, I can do negatives. If I made this -2, -2, -2, -2 times -2 times -2 is -8. So the cube root of -8 is -2. The cube root of -1, if I make these negatives, -1 times -1 times -1 is -1. So the cube root of -1 is -1. And you can see that all of those are nice values. So if I'm graphing this, I have 0, 0. I have -1, -1. I have, where's the next one? -8, -2. I have +1, +1, +8, +2. So I'm picking numbers that I can take the cube root of. I can take the cube root of -8, -1, 0, 1, and 8. And I really want to actually extend this. I don't want to leave these points. If I only do these 3 points, what ends up happening is students usually do this and make it look like that, when in fact it actually looks like it doesn't look like it, but this is actually going up and this is actually going down. It's just very slow. So that means that this function's domain is -infinity to +infinity. The range, it's going up, it's going down, is -infinity to +infinity. It's just very slow. This function is only increasing, and it's over its entire domain, so it's never decreasing. So the only time it's going to decrease is when we make our a value negative, and then we flip the function, which we'll talk about more tomorrow. Okay. A parent function is a function where no transformations have occurred. So when we talk about vertex form, a times x minus h squared plus k, that would be when our h and our k are 0 and 0. So meaning a times x minus 0 squared plus 0. Well, x minus 0 is just x, so we get ax squared, and then we end up getting our plus 0. So that's why we end up having y equals x squared at the origin, because our h and our k haven't been moved up or down. Okay, that's exactly what this is saying, but for all functions. So square root, cube root. Okay, so we're going to talk about this more tomorrow, more on Monday, but that's the biggest things is we've been using the a value for x squared, over 1 up 1, over 2 up 4, over 3 up 9. Now we're going to talk about square root, where we say over 0 up 0, because I'm taking the square root of it. Over 4 is the square root of 2, or is 2, and then over 9 means the square root of that's 3. And then we get down to here, and we say that I can start taking the cube root of a couple numbers. So I'm going to take the cube root of 0, of 1, of -1, of 8. Okay, so hopefully those will become a little bit more familiar. And then we'll talk about what each of these does. Okay, and then we'll fill this out with our notes on Monday. All right, thank you.